Hey everyone! Welcome back to ISRC. Today, we are diving into a super exciting project, building a line-following robot from scratch. Section 1, Materials and Tools. Before we get started, let's go over what you'll need for this project. Here's a list of materials and tools. Microcontroller, like an Arduino. Motor driver module, L298N or similar. DC motors with wheels. Infrared, IR, sensors. Battery pack. Chassis. Jumper wires and connectors. Screwdriver and screws. Breadboard and protoboard. Soldering kit. Got everything? Great! Let's get started. Section 2, Assembling the chassis. First up, let's put together the chassis of our robot. If you have a pre-built chassis, you can skip this part. Otherwise, follow the instructions provided with your chassis kit. Attach the motors to the chassis using screws and make sure they're securely fastened. Now, add the wheels to the motors. They should click into place or screw on easily. Section 3, Connecting the motors. Next, we need to connect the motors to the motor driver module. The motor driver controls the direction and speed of the motors. Connect the motor terminals to the output pins on the motor driver. Make sure to connect the motor driver to your microcontroller as well. You'll typically need to connect power, ground, and the control pins. Section 4, Adding the IR sensors. Now it's time to add the IR sensors. These sensors will detect the line on the ground and help your robot follow it. Mount the sensors at the front of the chassis, making sure they're positioned close to the ground. Connect the sensors to the input pins on the microcontroller. Section 5, Wiring everything up. Step 1, Motor driver connections. Connect the motors to the motor driver. Attach the wires from the left motor to the motor A output terminals on the motor driver. Attach the wires from the right motor to the motor B output terminals. Connect the motor driver to the microcontroller. Use jumper wires to connect the input 1, input 2, input 3, and input 4 pins of the motor driver to the microcontroller's digital pins. The ENA and ENB pins control the speed of the motors, so connect them to PWM-capable digital pins. Power and ground connections. Connect the 12-volt and ground pins of the motor driver to your battery or power source. This will provide power to the motors. Make sure to also connect the ground pin of the motor driver to the ground of the microcontroller to ensure a common ground. Step 2, IR sensor connections. Position the IR sensors. Mount the IR sensors on the front of your robot, close to the ground, ensuring they're evenly spaced. Connect the sensors to the microcontroller. Connect the VCC pin of each sensor to the 5-volt pin on the microcontroller. Connect the ground pin of each sensor to the ground pin on the microcontroller. Connect the output pin of the left IR sensor to analog pin 0 and the output pin of the right IR sensor to analog pin 1. These pins will read the sensor values to detect the line. Double-check all connections. Ensure that the power and ground wires are securely connected and that each component is wired correctly to the appropriate pins on the microcontroller. Section 6, Coding the robot. Time for the fun part, programming. We'll write a simple program to make our robot follow a line. Here's a basic sketch for Arduino to get you started. We have provided link for the code in the description. Let's break down this code for a line-following robot part by part. Library inclusion. The afmotor.h library is included to control the motors using the Adafruit motor shield. This library provides functions to control the motors connected to the motor driver. Sensor and motor pin definitions. Left sensor and right sensor are analog input pins, a 0 and a 1, connected to the robot's left and right line sensors. Left motor forward, left motor backward, right motor forward, and right motor backward represent the digital output pins controlling the robot's motors. These pins are connected to the motor driver to control the movement of the left and right motors in forward and backward directions. Setup function. The setup function runs once at the start. It configures the sensor pins, left sensor and right sensor, as inputs to receive analog data from the line sensors, and the motor pins, left motor forward, left motor backward, right motor forward, right motor backward, as outputs to control the motors. Loop function. In the loop function, which runs continuously, the sensor values are read using analog read. These values are stored in left value and right value, representing the intensity of light or reflection from the surface. A higher value, above 500, typically means the sensor is detecting the white surface outside the line, while a lower value, below 500, indicates the sensor is over the black line. Movement control logic A moving forward. If both sensors detect the black line, values below 500, the robot moves forward. Both motors are activated in the forward direction. Turning right. If the left sensor detects the white surface, value above 500, it means the robot has veered left. To correct its path, the robot turns right by driving the left motor forward and stopping the right motor. Turning left. If the right sensor detects the white surface, value above 500, the robot has veered right. It corrects by turning left, activating the right motor while stopping the left motor. Stopping. If neither condition is met, which is unlikely in this scenario, the robot stops by turning off all motor outputs. Upload this code to your microcontroller, and your robot should start following a line. Section 7. Testing and Calibration. Let's test our robot. Place it on a track with a clear line and watch it in action. You may need to adjust the sensor values or motor speeds for better performance. With a bit of tweaking, your robot should follow the line smoothly. Make sure to calibrate your sensors and tweak the code as needed. And that's it. You've successfully built and programmed a line-following robot. Thanks for watching. For more information, contact us today. We are on a mission to train over 10 million teachers in the field of STEM and practical learning by 2030. We have our connections in UAE, Nepal, Kuwait, Oman, Bahrain, Saudi Arabia and Qatar. Our international offices exist at South Africa, Oman, UAE and Dubai. We have our head office at Mumbai, India.